All right, the second thing we're going to talk about is precise definitions. So having an accurate definition that is necessary and sufficient in describing what you're trying to say is extremely important in geometry. And so to do this, there's kind of three things we want to do. The first thing is we're going to classify what it is that we're trying to define. So that's basically saying, what is it? And then you're going to say how it differs from everything else that might fall into that category. And then you're going to test it. And when you test a definition, you're looking for counterexamples. Counterexamples are just examples that would counter or cancel out your definition. All right, so in this example, if I'm going to define a protractor, which a protractor is a tool that you use to measure angles. So in this, the first thing you want to do is classify. So when I classified it, so let's classify. Classifying a protractor means it is a geometric tool. All right? How does it differ from all other geometric tools? So there's like rulers and different things. How does that differ? Well, it differs because it's used to measure angles. So that's how most definitions work. And then you want to test, okay, well, are there any other tools that we use that measure angles? Or is there anything that's a protractor that's not used to measure angles? That's when you're looking for counterexamples. All right, so in this case, if I want to define different types of angles, there's three main types of angles: right angles, acute angles, and obtuse angles. And before I even tell you what those are, I want you to look at these definitions. So if I told you that these three were examples of right angles, and these two were not right angles, what would you do? What would your definition be? Okay, so first thing you want to do is what? First thing you do, pull this back up, classify. What is it? Well, right angles are types of angles. So right angles are angles that, second thing we want to do, how does it differ from the others? So this differs in that, let's look at it. So this is 90 degrees. This form right here, when you put a little square, the square for an angle means that it's 90 degrees, that the measurement of that is 90 degrees. And this one also has a box. So all of these are going to be 90 degrees. And two examples that are not right angles, 105 and 20 degrees. Both are not 90 degrees. So right angles then are angles that are 90 degrees. All right, so I want you guys to come up with two, well, let's do one more together, and then I want you guys to come back with the obtuse one. All right, so acute angles then, these are examples of acute angles, and these are examples, are counterexamples to that, are not acute angles. This would tell us that acute angles are angles that are less than 90 degrees. Acute angles are angles that are less than 90 degrees. That holds true for this, and all of these are false because they are 90 degrees or greater. All right. I want you guys on your own to come up with this final example. So obtuse angles then, make your definition. All right, so the final thing we're going to talk about here is angle bisectors. Angle bisectors are rays that divide an angle into two congruent angles. So your initial angle here was angle MPR. This right here. Your angle bisector is initial, let's go ahead and write this out, angle. All right. Your angle bisector then is a ray, and it is a ray PN, from P to N. And this would be your angle bisector. All right, and the congruent angles, because your two congruent angles are right here. And notice how those two have the same line. I can also you could put it like this, you can do like that. You can also see sometimes they draw two like this. That's probably more common. Any of those would define angles that are congruent. All right, and so because if we want to label this out, MPN is congruent to angle NPR. All right. Questions, comments, concerns?